Life. Do you know what life is? This is cosmic dust, a random temporary phenomenon, a zero without a stick, a bald spot on a bare spot, having no meaning in the vastness of the endless stage of the universe. How many times have you heard such derogatory statements about this thing we call life? The most mysterious phenomena in the universe. Black holes, magnetars, and dark matter are not the most mysterious. We see traces of their existence everywhere against the backdrop of the whole cosmos. It is life that looks like some kind of anomaly. Only the manifestation of life has not been encountered by us anywhere outside of our planet. Life. What is this? Among hundreds of trillions of kilometers of emptiness and rocks and gas, something so strange appears that it is capable of opposing itself to everything else. We are living people, flesh and blood of the universe that we see, and we are very definitely part of it. At the same time, the universe does not seem alive to us. But have you ever wondered what the fundamental difference is? What is the difference between living and inanimate matter, and where is the line beyond which one ends and the other begins? If you look through the eyes of an ancient person, then the differences are obvious. Inanimate matter, for example, a huge stone in the dark may well resemble a living bear, but only living matter. A living bear can chase you in the forest, and no matter how much you rush among the trees, catch you and tear you to pieces. Inanimate objects never do anything so purposeful. A huge boulder rolling down a mountain is not actually pursuing you, so ancient people reason. No wonder. After all, they had never seen homing missiles. Since ancient times, it was believed that something was needed, some kind of weighting factor, forcing one matter to behave very differently from another. Aristotle, for example, believed that the peculiarity of living things is the ability to initiate movement without external influence. He believed that when the same boulder that rolled down the mountain stops, it will never move again until something or someone has an impact on it. But living matter, for example, a sleeping bear, can be at rest, and then, without any influence, take it and begin to move. But Aristotle was wrong. Modern science easily reveals the weakness of such generalizations. We can say that the bear also begins to move solely due to external influences. For example, due to rising temperatures. The change in temperature changes the chemistry of the process in his body, and he wakes up. But on the other hand, the uranium nucleus, which we definitely do not consider alive, can remain unchanged for billions of years. And then abruptly and suddenly, without any external influence, it takes over and disintegrates. In some ways, Aristotle was absolutely right. He was right in calling life a fundamental phenomenon of nature. You will say for everything in the time of Aristotle, almost everyone thought this way. They thought that the universe mainly consists of what we now call the biosphere of the Earth. If the Earth's biosphere is the main thing you see and know about throughout your life, then naturally you will think that trees and animals are at least as important as rocks and stars. Yes, indeed, only hundreds and hundreds of years later, discoveries in the field of astrophysics demonstrated that the universe is not only huge and absolutely indifferent to the Earth, but also that it is described by universal laws that do not mention life at all. Charles Darwin explained to us the origin of life in a language that does not require any specific knowledge. And even today, having discovered and studied many of the subtlest mechanisms of life, we have not found any special physics in them. After all this, it would be simply ridiculous to continue to call life a fundamental phenomenon of nature. The very concept of nature in a broad sense has become identical to the concept of physics. From the point of view of the modern layman, the differences between living and inanimate matter will also almost always be obvious. At the macro level, we distinguish living from non-living. Well, by eye. But if we take every living creature and disassemble it into atoms, we will see that these are one in one the same atoms that make up the stars and planets. And the same atoms form what is alive and also what is not alive. What makes inanimate matter alive? No one has ever been able to find that very magical property that distinguishes living beings from inanimate objects. For a long time after Aristotle, we continued to miss. The main true understanding of what living matter is eluded us. And so modern biology no longer expects to discover something that gives life to matter. For we were finally able to find the very basis of life. The first one, if you like, is where it all begins. Imagine a pile of stones that is methodically thrown into the air over and over again. After each throw, there is a non-zero probability that the stones will fall on top of each other, forming a certain structure, and this structure will have a set of properties that just a pile of stones itself does not possess. That is, it will be more than just the sum of its parts. This phenomenon is called emergence. Emergence is the appearance in a system of properties that are not inherent in its individual elements. There are many examples of such synergy in nature. Of course, some trainers are less likely to exhibit emergent properties, and some are more likely. A little further, you will understand what is meant. By combining certain atoms in a certain sequence, we get a structure with properties that a simple bunch of the same atoms does not have. The name of this structure is molecule. Now we understand that the basis of life is not at the level of individual atoms. It is located higher. The basis of life is molecular. And the distinctive property of living molecules is that they provoke the environment in which they are located to copy themselves. Yes, some atomic configurations do tend to replicate. That is, to create copies of ourselves with the help of the environment. We call such configurations of atoms genes. A gene is an emergent property of atoms, the same emergent property as the complex fractal patterns of a snowflake, or a row on a sand dune, or a giant geometrically regular hexagon on Saturn. The appearance of these emergent properties is, of course, much more likely than the origin of life. But nevertheless, all of the above are nothing more than systemic effects. That is, atoms themselves are not alive. But as soon as they are combined in certain sequences, their emergent property immediately manifests itself. A synergistic effect in which this configuration of atoms will begin to order the environment in a certain way, creating similar configurations of atoms. There are a lot of examples of emergence in nature, and even if I wanted to, I could not list even a small part of them. Therefore, it is not surprising that no special physics was found in living matter. For the emergent property of physics is chemistry, and the emergent property of chemistry is biology. Piece by piece, atoms come together to form molecules, which in turn form entire organisms. That same magic, which when trying to find in living organisms, is nothing more than a manifestation of the emergent properties of matter, when at the micro level, new elementary processes together create phenomena that are incredibly complex at the macro level. For the same reason, people who look for the center of consciousness in the brain have very little understanding of what they are doing. So one day on planet Earth, no one still knows exactly how and where exactly. Matter exhibited an extremely rare and very, very unlikely emergent property, namely under unique, favorable conditions. The first replicator spontaneously appeared from a bunch of atoms. Having appeared, it began to multiply, and that's all. Having uncontrolled reproduction with limited resources, we get competition. Self-operation of replicators does not occur ideally, due to which mutations occur. Mutations generate variations in genes, which in turn generate variations in species. Competition plus species variation equals natural selection. Natural selection plus time equals evolution. Yes, all life on the planet is based on replicator molecules, which we call genes. Thus, in the universe, there is no division between living and non-living matter. Matter is the same, and life is simply its emergent property. Just? But does this somehow answer the question of what life is? Take your time. A gene is the smallest indivisible element of hereditary material that can be passed on from parents to offspring. Genes determine the entire organism, what it will be like, what its functions, characteristics, and properties will be. Genes are the instructions by which the entire body is built. Modern science tells us that what an organism will be is determined by genes only half. The other half is determined by the environment. This formulation really infuriates me because as it is, it gives a poor understanding and diminishes the true meaning of genes. Roughly speaking, it's as if tomato seeds could sprout red cacti if planted in the desert. From my point of view, a good formulation would sound like this. Genes imply some variability in the characteristics of an organism depending on environmental conditions. So a gene is able to replicate only in a certain habitat or niche. A niche is the environment in which an organism can survive and produce offspring. And what is characteristic from this point of view is that the organism itself is a niche for genes. You probably haven't understood the joke yet, but you will soon. Richard Dawkins, whom for some reason everyone knows only as the main atheist on the planet, actually has much more impressive merits and initially became popular for no reason at all. Dawkins published the book The Selfish Gene in 1976, in which he greatly deepened the theory of evolution. Unlike Darwin, who believed that the fittest version of the species survives, Dawkins argues that it is in fact the fittest version of the gene that survives. Thus, all of evolution ensures the well-being of the genes that are copied best. Yes, the unit of evolution is the gene, and not the organism, as many believe. For example, the genes for a huge peacock tail clearly do not make life easier for an individual peacock or for the entire peacock species as a whole. But it was these genes that turned out to be the most successful in comparison with their direct competitors. Hence the name, selfish gene. The main feature of a replicator is that it is always the cause of its copying. That is, it forces the environment to copy it. Thus, biology is, first of all, think about it, the science of studying the influence of genes on other matter. What is a bear? This is a huge repository of genes. Take, for example, the insulin gene cannot replicate itself. The presence of all other genes in the bear's body is critically important to him, but that's not all. It also needs genes from other organisms in the external environment. A bear cannot survive without food, and the genes to make that food are only present in other organisms. So the genes work together to design the bear's body, telling it to do many different things, including hunt, so that the genes can copy themselves. The bear's body is the closest environment that genes manipulate to replicate themselves. Do you understand? They create a bear and program its behavior, forcing the animal to follow algorithms aimed at copying. No, not the bear, but those genes that are in its body, and do it at any cost. Note again that the bear itself is not a replicator. During reproduction, the bear is not copied, and even less does it induce its own copying. A new bear is created anew according to the blueprints embedded in the DNA of the parent organisms. The organism itself is not a replicator, it is part of an environment of replicators. Usually the most important part after all the other genes. The rest of the environment is the type of habitat that the organism can occupy, such as the top of a mountain or the bottom of the ocean, and a specific lifestyle in it, for example, a hunter or a filter feeder, which allows the organism to live there long enough for the replication of its genes to occur. Thus, an organism is the closest environment that copies real replicators. That is, the genes of this organism. Previously, for example, a bear in its den would have been classified as a living and non-living object, respectively. But there is no fundamental difference at the basis of this division. The role of a bear's nose is not fundamentally different from the role of its den. Neither one nor the other is a replicator, although new examples of both are constantly being created. Both the nose and the den are just parts of the environment that bear genes manipulate as they replicate. Genes that require cooperation to replicate are linked together in long chains called strands of DNA. Based on these chains, various organisms are built, for example, microbes, plants, or animals. We think of these organisms as living. But from what I have said, it follows that living, in relation to parts of the body other than DNA, is, well, at best a courtesy title, nothing more. This understanding of life, in which organisms are viewed in relation to genes as part of the environment, has been contained in the foundations of biology since Darwin, but it was hardly noticed until Richard Dawkins's Selfish Gene in '76 in the extended Phenotype. 82. Living molecules, genes, are simply molecules that obey the same laws of physics and chemistry as non-living ones. They do not contain any special substance and have no special physical properties. They simply turn out to be replicators in certain environments. More precisely, not even like that. A gene can be a replicator most often only in a very limited number of environments, while in a huge number of other environments, it will not be a replicator. So why did I suddenly decide that life is a fundamental natural phenomenon? Why is she worthy of this status? What is so special about life in the vastness of the endless universe? After all, its influence seems negligibly small. We don't know if there is life beyond the Earth until we've encountered it. But even if it is widespread, its manifestations are apparently too insignificant to be registered. Looking into the sky, we see an active universe, overflowing with a variety of powerful but absolutely inanimate processes. Galaxies rotate, stars condense, ignite, burn, explode, and collapse. High-energy particles, electromagnetic gravitational waves propagate in all directions, and it seems not very important, is there life among all these tectonic processes? For it is unlikely that she can influence at least one of them. If a huge solar flare engulfed the Earth, which in itself is an insignificant event from the point of view of astrophysics, our biosphere would instantly become sterile. But this catastrophe would affect the sun to the same extent as a drop of rain would affect an erupting volcano. Our biosphere, taking into account mass and energy, is a tiny, insignificant part of even the Earth. At the same time, if we talk about mass, the solar system is called solar for a reason. It is a truism in astronomy that the solar system consists primarily of the sun, whose mass is 740 times that of all the local planets combined. Yes, the solar system is mainly the sun, and maybe to some extent Jupiter. With this kind of mathematics, everything else in the solar system, except the sun and Jupiter, can be called simple impurities. Moreover, the entire solar system is a negligible component of the Milky Way, a galaxy that itself is unremarkable among the many others in the known universe. Stephen Hawking once said, "The human race is just a chemical sludge on a medium-sized planet orbiting an ordinary star on the outskirts of one of hundreds of billions of galaxies." I probably don't know anyone who would argue with this. Yes, but this is not true. Can you hear me? This view is the deepest delusion of our time. Ask yourself the question: the basis of life is the gene. What is it? A gene is a piece of hereditary information. A bear, a person, flowers, bacteria, everything that we conventionally call life. These are all just ways in which genes copy themselves. Methods. The more accurate information about the environment a gene contains, the more successful it is in terms of its reproduction, because the gene has reliable information about the environment and can live in this environment and reproduce in it. Genes with more accurate information about the world displace genes with less accurate information. The vast majority of genes containing incorrect or inaccurate information about the environment were unable to survive in it long enough and/or replicate. The fittest to the environment survives, right? What is adaptation to the environment? Adaptation to the environment is the presence of reliable knowledge, that is, objective information about this very environment. It's not that genes can know something, but evolution is when, through a brute force method, those genes that have less complete and less reliable information are eliminated. The human eye is not ideal. We cannot even understand how far it is from seeing the universe this way, what it is. But it turned out to be good enough for people to perceive things more or less accurately. And, of course, thanks to a combination of factors, stand up with the most effective view on the planet, and all because the genes responsible for the formation of the human eye store sufficiently accurate information about the surrounding world so that the whole organism can adequately perceive this world. And this applies to all living things. Genes carry out very precise interactive control of the reactions of the complex environment of the body to everything that can happen to it. And this control is aimed at causing a very specific response of the environment to genes, namely replicating them. Moreover, the more external situations genes are able to digest without dying, the more successful they are. In this context, the human brain is potentially the best that genes have been able to build. Well, from what we know, the more information about genes corresponds to environmental conditions, the more copies of themselves these genes will leave. Thus, we can say that evolution is essentially a kind of computational process, and genes are literally embodied information about the environment. Realize this: all the sensory experiences you experience while living your life, the colors and geometry you see, the sounds you hear, the hardness or softness of the ground under your feet that you feel, Your ability to move through space and your ability to feel that water is wet and mud is sticky. Feel the play of the wind on your skin after all. You have manipulators in the form of hands. All this did not come out of nowhere, but from the fact that over millions of years through evolution, genes were developed that carry the most reliable knowledge about the environment. This knowledge is embodied in you. It is through this embodied knowledge of the world that you are able to interact interactively with the environment, receive stimuli and respond, and vice versa. You yourself are also capable of giving stimuli to the environment, receiving a response from it. Humans do not have the genes to see the full spectrum of electromagnetic waves or all the measurements predicted by EM theory. Due to the absence of some genes, perhaps some things in the universe are fundamentally unknowable to us, and perhaps this is for the better. But we have genes that give us a predisposition to unprecedented abstract thinking, thanks to which we can learn about some phenomena that are inaccessible to us at the level of feelings. That is, genes carry knowledge about their niches. Everything that has fundamental significance, the relative phenomenon of life, is determined precisely by this property and not by replication itself. The presence of reliable knowledge is primary because genes with unreliable knowledge are not viable and quickly die out. Genes that reproduce the environment less accurately are always inferior to genes that reproduce it more accurately. In this case, we are talking about better adaptation of genes to their niche. Why is it primarily the presence of reliable knowledge and not reproduction? Because we can imagine a type of gene that is not capable of replication, but is adapted to maintaining its form from external influences, for example, capable of resisting corrosion and other destruction. It is unlikely that such a species could appear naturally, but it could be created artificially. Once the production of these artificial organisms stops, the number of examples of each non-replicant gene can no longer increase, but it will not decrease until the consciousness that these genes contain is sufficient to implement the survival strategies of these genes in the niche they occupy. And here it becomes clear to us that the survival of currency knowledge is fundamental, and not necessarily the gene or some other physical object. Therefore, strictly speaking, some part of knowledge is adapted to the niche and not a physical object. If adaptation occurs successfully, then the properties of this knowledge appear. Once embodied in this niche, knowledge will tend to remain there. The gene, in the form of its physical shell, is not so important, because on the one hand, in the case of a replicator that implements its physical material, the material is constantly changing. A new copy is assembled from non-replicant components at each replication. On the other hand, non-replicant knowledge can also be successfully embodied in various physical forms, as for example in the case of transferring an old recording from a vinyl record to magnetic tape, and then to a CD and so on. In the end, perhaps people will one day copy the knowledge contained in their genes onto the most reliable medium available to them in the future, replacing all their fragile biology with something more durable. And it would be strange to call these people of the future inanimate, because if you, for example, do not believe that the body is some kind of special vessel for the soul, but at the same time declare that artificial intelligence is impossible, then this is the same thing. This is literally the same as saying that the brain is not a physical object. But terminology isn't that important here. The point is that although all known life is based on replicators, it is really built around one single phenomenon: knowledge. In that case, what is life then? Life is the physically embodied knowledge about a niche, which forces its niche to maintain the existence of this knowledge. And I understand perfectly well how a bunch of words, and at the same time crazy this may seem, if you haven't properly grasped what I was saying. But this is perhaps the deepest definition of life that we can give, summing up all of the above. However, any skeptic will stop me and say that knowledge is an anthropocentric human concept. That is, knowledge is the thing that is important to us people, because our ecological niche depends on the creation and application of knowledge. Outside of man, this concept has no meaning and is not important to the rest of the universe. But the skeptic would be critically wrong. Knowledge is important not only for Homo sapiens and not only on planet Earth. Let's look at the astrophysical consequences of knowledge. Today we have a cool theory, stellar evolution, which describes the structure and development of stars. But some 100 years ago, we didn't even know the source of solar energy. The best physics of that time did not give only the false conclusion that whatever the source of its energy, the sun could not shine for more than 100 million years. Then nuclear physics was discovered and applied with all its subtleties to the physics of stellar interiors. Now we understand why the stars shine. For most stars, we can determine what their temperature, color, luminosity, and diameter were at each stage of their existence. Find out the duration of each of these stages, say what elements the star creates through nuclear transformations, and so on and so forth. This theory has been tested many times and supported by observations of the sun and thousands of other stars. We can use this theory to predict the future development of the sun. Is it talking? It says the sun will continue to shine with great stability for about 5 billion more years. Then it will increase 100 times and become a red giant. Then the outer shell of the sun will dissipate into the surrounding space, forming the so-called planetary nebula. The exposed core will become a gradually cooling white dwarf. I think you know all this. After tens of billions of years, the white dwarf will cool down so much that it will not produce visible radiation, becoming a black dwarf. But will all this actually happen to the sun? Is it possible that every star of the same mass and composition that formed 5 billion years before the sun has already become a red giant, as the theory predicted? And is it possible that some seemingly insignificant chemical processes on the tiny planets orbiting these stars could change the course of such cyclopean processes? Is it possible that a pile of chemical dirt could influence nuclear and gravitational processes of an unimaginable scale, which operate with immeasurably greater mass and energy? If the sun does become a red giant, it will engulf and destroy the Earth. And if by that time there are still our descendants on Earth, they most likely will not want this to happen. They will do everything in their power to prevent this. Are we 100% sure that they won't be able to do anything? Of course, our current technology is too weak to cope with such a task. But this does not mean that this task will remain unsolvable in the future. Moreover, we already know in approximately general terms what will be required to solve it, namely the removal of the matter of the sun. And we still have as much as 5 billion years left to perfect our crude plans and put them into practice. And now attention, if our descendants save themselves in this way, it means that our modern cool theory of stellar evolution, when applied to one specific star, the sun, gives an absolutely wrong answer. And the reason for this is that it does not take into account one of the fundamental parameters. It takes into account fundamental physical effects associated with nuclear and electromagnetic gravitational forces and hydrostatic and radiation pressure. But not life. It does not take into account the influence of life on stellar evolution. Do you understand? It is impossible to predict the future sun without taking into account the future of life on Earth, and in particular, future knowledge. The light of the sun in 10 billion years will depend on gravity, radiation pressure, convection, and nucleation. It doesn't depend at all on geology, Venus, the chemistry of Jupiter, or the pattern of craters on the moon. But it does depend on what happens to life on planet Earth. It depends on politics, economics, and the outcome of the war. It depends on what people do, what decisions they make, what problems they pose, what values they cultivate, and how they behave towards children. Such a theory follows neither the law of physics nor any other fundamental principle known to us. It can only be proven in high-level human language. Thus, theories about the activity of life are necessary for astrophysical predictions. Even if you are the ultimate skeptic and pessimist and do not believe that life on Earth will last that long, you still cannot escape the same conclusion. For even if the human race's attempts to survive ultimately prove futile, the cosmos is vast. And if some intelligent life in some galaxy ever manages to survive for billions of years, then this means that life is inevitably important in the general course of the physical development of the universe. Thus, throughout our galaxy and every other galaxy, stellar evolution depends on whether, when, and where intelligent life evolved. Yes, but so far we have not received a single reliable confirmation of the presence of extraterrestrial life, much less extraterrestrial intelligent life. At this point in the universe as we see it, life has not affected anything that has any astrophysical significance. But as you know, The speed of light is sharply limited on the scale of the universe. And looking into the sky, we see the past, and in more or less detail, we see only the past that is spatially close to us. The further into the universe we look, the more distant the past we look into, and the less details we see. And this can happen there, As our theories about the structure of the Milky Way become more refined, we will be able to make more accurate predictions, but again, only based on assumptions, the distribution and behavior and intelligent life in the galaxy. If these assumptions are not accurate, error in predicting the distribution of spectral types will be almost as inevitable and gross as if we were mistaken about the composition of interstellar gas or the mass of hydrogen atoms. Cosmologists John Barrow and Frank Tipler looked at the astrophysical manifestations that life would have to survive long enough. They discovered that life would eventually bring about enormous qualitative changes to the structure of the galaxy, and subsequently the entire universe, and that in the end it is quite capable of seizing dominance over everything that happens, just as it now dominates the Earth's biosphere. Any theory of the structure of the universe in all but the earliest stages must be guided by what life will or will not be doing by that time. This cannot be avoided. One cannot ignore the fact that the future of the universe depends on the future history of knowledge. We are accustomed to justify the small significance of life by placing too much weight on general quantities such as size, mass, and energy. From the point of view of modern science, these are really good measures of significance. But in the context of life processes, they are poorly applicable. Therefore, there is no reason in physics why it should remain this way. The biosphere itself already presents many counterexamples. For example, in the 3rd century BC, the mass of the human race was only about 10 million tons. One could conclude that it is unlikely that the presence of such a small biological mass could cause some physical processes that led to the movement of many times larger masses. However, it was at that time that the Great Wall of China was built, weighing 300 million tons. That is, 30 times more. Moving billions of kilograms of rock is one of those things that people do all the time. Today, only a few dozen people are needed to dig a railway tunnel, removing millions of tons of earth. These thoughts are even stronger if we more fairly compare the mass of the stone moved with the mass of that tiny part of the brain of the engineer or emperor in which the ideas were embodied and forced to do this work. 100 years ago, we heated our stoves with wood. Now, the human race may already have enough knowledge to destroy entire planets if its survival depended on it. Even non-intelligent life has significantly transformed the substance of the Earth's surface and atmosphere, which is many times greater in mass than itself. All the oxygen in our atmosphere, about 1,000 trillion tons, was created by plants, and therefore became a side effect of the replication of genes, that is, molecules of the descendants of one single molecule. Life has an impact not because it is characterized by greater size, mass, or energy than other physical processes, but because it has greater knowledge. In terms of the macroscopic effect that knowledge has on the results of physical processes, it is at least as important as any other fundamental physical property. But there's something else. Let's compare a living bear with the constellation Ursa Major. Living bears in many nearby universes are anatomically very similar. Not only their genes, but their entire body has this property. However, in the constellation Ursa Major, there is no such regularity from one universe to another. The shape of the constellation is highly susceptible to the phenomenon of chaos and will depend entirely on the initial state of the galactic gas from which the stars were formed. This condition was accidental. At the microscopic level, it is quite random in different universes, and the process of star formation from this gas involved all sorts of instabilities that increase the scale of variation. As a result, the arrangement of stars they observe in a given constellation only exists in a very limited range of universes. In most close variants of our universe, there is also a constellation in the sky, but they look different and even completely different. In a single universe, the most striking structures are galaxies and clusters of galaxies. Isn't it true? But these objects have no discernible structure at all in the multiverse. Where there is a galaxy in one universe, the multiverse contains myriads of galaxies with very variable geographies. Close universes seem to share only certain common features, as required by the laws of physics that apply to them all. Yes, most stars have a fairly accurate spherical shape throughout the multiverse, and most galaxies have a spiral or elliptical shape, but nothing extends very far into other universes without changing the details of its structure beyond recognition. Except in those few places where there is embodied knowledge, in such places objects extend across a huge number of universes while remaining recognizable. The genes with the best adaptation will have the same structure across a wide range of universes. If only you could observe through a telescope, the entire multiverse of life and its consequences would be obvious at first glance. Places in the universe touched by life would be different from other places, just as satellite images show waste fields and wild jungles. How crystals differ from the solution in which they grew. And despite the apparent insignificance of life, it is precisely life that gives rise to the largest scale, regular discernible structures in the multiverse. Thanks for watching. Subscribe to the channel and like the video.